Hi, I'm Keng Hong Shen from the Movement and Cognitive Rehabilitation Science program. In this study, we're investigating the changes in stepping biomechanics after 6 weeks of perturbation-induced lateral weight transfer training in individuals with chronic stroke. So after stroke, people commonly have difficulty transferring their body weight towards the paralytic lower limb during voluntary movement. So on the screen, you can see the impaired weight transfer can be visualized by the magnitude of gravitational forces during walking. This insufficient weight transfer will affect propulsive force and decrease walking speed. So restoring weight transfer ability is a major goal during rehabilitation. Successful weight transfer requires timely and sufficient lower limb loading, which is barely achieved voluntarily during conventional therapy. So we've developed a perturbation-based training paradigm that targets paralytic limb loading ability, aiming to improve weight transfer during voluntary movement. So here's a demonstration of perturbation. The support surface drops 4.3 centimeters beneath the paralytic limb. So the perturbation will force the participant to load their perturbed limb and shift their body center of mass towards the drop side. So each training session included 50 perturbations delivered to the paralytic limb in chronic stroke participants. And the entire training program was consisted of 3 sessions per week for 6 weeks. I want to see if this training really can improve voluntary weight transfer. But how do we measure voluntary weight transfer? Because transferring body weight towards the stance limb is required during voluntary stepping. So we use the stepping test to measure the weight transfer performance before and after training. Specifically, clinical step tests and choice reaction stepping were assessed. The choice reaction stepping started with a light cue, indicating the instant and the limb used to take a forward step. So after the light cue, the participant processed the information and began to load their stepping limb in order to transfer body weight towards the stance limb. So finally, the stance limb was fully loaded and the step limb was lifted off the ground. After understanding the training and weight transfer assessment in this study, let's take a look at the results. So preliminary results for 6 individuals post-stroke were analyzed. And because we're studying the paralytic limb loading, so data with non-paralytic limb as a stepping limb were analyzed. After 6 weeks of training, we observed a trend of 1.6% increment in paralytic stance limb peak weight bearing, and 18.9% increment in paralytic stance limb knee extension torque. So those results indicating an improved limb loading ability. And the improved limb loading ability may contribute to more efficient stepping, as demonstrated by 13.4% reduction in weight transfer time and 18.1% improvement in step test score. So in conclusion, our study suggests that perturbation-based training that targets paralytic limb loading can enhance voluntary weight transfer towards the paralytic limb. And assuming that the average and standard deviation doesn't change with additional subjects, power analysis show that statistical significance can be achieved with 10 more subjects. In the future, we'll compare the efficacy between this training program and conventional therapy. And positive outcome will motivate the development of a portable training system with our perturbation. So thank you for your attention. Please feel free to contact us if you have any comments or questions. Hope you're enjoying the CARE Research Day.